Hey everyone, welcome back to my workbench. It's not going to be too long today. Um, so, Still working on the Alcan. So, two things. I got to ohm out this controller here to figure out which pin actually goes to which. Because I know what the colors mean, I just don't know where the DB9 goes to. So I can make up an adapter. Try out the SNES cable. So I was doing a little more research into the sound chip of the Alcan, and it answered a question I had, which I didn't ask yet. I noticed when I was doing the controller, figuring out which was which, I was getting, I don't know how to describe it, a clock skew or jitter that went along with the audio of the game. So, and I did a little digging on the chip itself, and even though it sounds a lot like a Yamaha chip, it's performs similarly. The way it does it generates sounds is old school, but what happened is they integrated the controller interpreter, what actually decodes the controller, into the sound chip. So when the audio is changing, it actually affects the clock skew or clock rate going out to the controller. Not a huge deal, but it's going to make it really difficult to emulate that kind of chip because it's a controller. It is a joypad controller chip and a sound chip, and I think it has one other thing integrated into it as well. So very odd. So it has like multiple functions, but it explains why there was an odd skewing on the clock signal and even the data signal coming out of it. It needs to be linked with the clock that's being used to generate sound. So, I mean, as long as everything's synced up, it's fine, but it's going to make emulation difficult. Anyway, so I'm going to figure out here what pin is what. Alright. So, where did it go? Here it is. Easiest way to do it is you just get yourself a little male DB9 here. How do you know if it's male or female? You look under the skirt. One's on the right. One. I'm gonna mark that. My eyes are getting old. One. This is one here. So first off, let's see. So middle pin white is on one. Pin two. Pin two's no connection. Pin 2 is no connection. Pin 3. Is on brown. Data. So they separate a pin. It's good practice, actually. Pin 4. No connection. Okay, so they separated each pin out, which is actually good. You're supposed to do that, particularly if you have clock signals. That is yellow. That is DB5. anything? Pin 7. Pin 7 will get something. Nothing yet. Pin 7. 5, 6, 7. It is the red. Red, which is a latch, or it's going to be flipped over with the latch and the. No, that should be fine. Yeah. These are going to be clock or the latch, which are very similar. 8. Should be no connection. Never assume. Nope, I was wrong. 8 is on orange, which is the ground. And then 9 should be no connection. Double check. So they basically did signal, skip, signal, skip, signal, skip. The outside, they had no connections, and then the 2 on the bottom of the ground, and looks like a latch. Alright, so yeah, now I know why there was a clock skew on that, and why things are acting strange there. Okay. Getting back to SNES. SNES side, let's write this down. No connection, no connection. Data. 5 is PS latch. 6 is clock. 7 is plus 5 volts. I hope it's the same format data, because if it's not, there's not much we can do. You'd have to like program an Arduino or something to emulate it, which I don't feel like doing right now. Hopefully they went very similar to the original. It keeps popping out. Okay. So that's on there. Let's see if I can figure out how to talk to this guy. So what it means is the clock signal is actually being generated by the system, not the controller. So I don't want to rip apart this controller. I need fairly long pins. My standard header pin isn't deep enough, so even if I strip it back, maybe. That is a long pin. I don't have a female for this one. Looks like... How did Nintendo do this? It looks like a pair of clips on the side. I did have the request to swap the colors around on this controller, but I don't know if that's possible, because they actually key these buttons. There's little tabs on there that key for whichever button's which. locks in 4 places. Well, in that case, I'm just going to make up a quick cable, and then I'll just strip out the ends longer, so, and tin them, and then shove them down in there, see if I can get this to work first before I make up a cable for it. So, turn my iron back on. I'll go with the same colors they did. Yellow. Red. Red, orange, brown. Red, orange, brown. And then I need a white. This will be really quick proof of concept. And go from there. Yes, that tone chip is really weird on the Alken. Yeah, I was wondering, it's like, why is the clock dithering all over the place? And it's like, huh, why is it going with the sound? And I looked it up and it's like, sure as heck. The sound chip and the controller chip are the same chip. Yep, 28. Nope, I don't need black. Okay. Little helping hands here. Remember, it's the opposite order now. Yeah, the one's on the left. Grandpa needs a magnifying glass. Well, happy Father's Day to all you fathers out there. I am a father as well. Oh. So I need 1 filter cup on 1, 3, 5, 7, 8. So 1 is white. Worst comes to worst, I'll buy a SNES extension cable and just use the end off of that. But this is just to see if it's going to work. There. Can't see what I'm doing here. I guess my eyes aren't that bad. Okay. Okay. 3 is brown. I just hope the data format's the same. Again, you'd have to create some sort of software to interpret the signals then. I don't think that'd be very fun. So, let's for the best. Brown's there. 5 is yellow. Turn this around so I can see it. To the left. Okay, so then 7 is red. 8 is orange. 7 is red. It's not. I mean, I'm surprised. Most of the engineering practices they did are fairly decent. Though I heard the capacitors, the original capacitors are quite awful, so. But it is a symptom of the 90s more than anything else. Alright, so other end, I'll strip these all back. Let's see how far. So pretty good strip length there. Twist those a bit. Good tin on there, just to thicken it up a little bit. Hey. Wow, that was longer than I thought. Okay, it's about 4 hours later. Yellow, brown. Which is data. Let's hope I make some decent electrical contact down in there. We'll see. We will see. Put a link in there. Brown is data line. It is on 4 down here. Next up we have white wire. White is clock. Hopefully this works. We'll see. Worst comes to worst, I'll flip those 2 lines around. I'm just hoping that the data format they chose is the same. White wire clock. Clock is down on 6. With a pretty deep pin in there. Okay. Orange. Orange is ground. very odd color for ground. Well, this is a very odd system. Again. And just on number 1. Most ideal would be a SNES extension cable and splice into that and put a DB9 on the other end of it. Good enough. And then finally we have a red wire. Give this about a 30% chance it'll work. All depends how closely they copy the Nintendo controller system. And this is the red wire, which is the PS latch, pin 5. I wish I had a better cable. Worst comes to worst, I'll open this up and just tack on some wires. This is more of a proof of concept here. Let's see. Too much crap on my workbench. Original controller. Okay, let's try that here. Baseball styled side scroller. Alright. Plug that in. Didn't freak out the system, that's a good sign. Nothing. Well, let me try flipping. Oh, it is working, but the button mapping's wrong. Okay, jump works. Oh, the data formats looks like it's wrong. That's your pause. Let me try flipping those over, but I got something going on there. Let's go with, we'll flip over the 5 and 6. flip over 5 and 6, but my worry is the byte order might be the wrong direction. Or I got a really crappy connection going on here, but I doubt it. 5 and 6. Let's flip those around and see what happens. Definitely goes the other way. Well, shucks. The B is the start button. Y is some sort of jump. Nothing, 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 nothing. So that's kind of my worry, is the data byte order would be wonky. Let's see if I can see it. Data's coming in on 4. No, it's actually coming in on brown 3. So hard to get a good connection on here. Let's get a bunch of garbage right now. Okay. Let's try this ground here. That's garbage. Here's your clock. Yellow is, I can't remember. Gotta go DC coupled. There's your 5 volts. That's your 5-volt line. Yeah, it's formats data. Data format's wrong. Shucks. Well, that's the problem. Is the long story short, give you a visual aid here. What's happening is the where's my boogie board? There it is. Long story short, what's happening is they both use the general style of data getting transmitted, where there's like there's a clock and there's like a clear to send latching signal, but the the Aken sends a normally low pulse with the this guy goes up high every time there's a clock signal. I'll confirm it later, but so there's a clock signal comes in here, and there's a latch signal when you press a button. So when you hit this latch signal, what happens is it goes up, has data coming down, and then it goes out. So depending on what's off here. So I see with the SNES, what's happening is it has a normally high signal with no pulse at all. So what's happening is it's just sending a duration of pulse when you press a button. So depending which different button presses you send, along with this confirmation pulse, the SNES can determine what's going on. But this is the format is just the logic is different because the Aken has this fixed pulses coming in, and this is when the data is actually being transmitted. Whereas this SNES, it's holding the signal high all the time, and then when the PC signal gets latched, it knows to look. That tells the controller monitor to look for a duration of pulse. So depending how long this pulse is what button combination you have. So you could probably do it with something like an Arduino where you just interpret it, but I am not the expert in that kind of thing. It would be a learning curve for me, so oh well. All I can say is I tried, and I could see by the previous person who worked on the system wasn't able to figure it out. You need a pretty fast scope and some knowledge of digital signal processing to know why you're having an issue. So, darn it. So close. But, we'll see where we want to go from here. Maybe I will buy an Arduino and give it a shot. I don't own one right now. And using like a Raspberry Pi would be complete like overkill for this sort of thing. But I'm thinking it can do something where it'll just simulate the signals coming off of here, translate it, and convert it into the Aken signal. But we'll see. I don't know how precious this thing is to Brandon. We'll find out. Everyone, thanks for watching, and happy Father's Day.